Hello, this is Mr. Schmidt, and I'm giving my first try at my own video, so hopefully this will give us a good background for tomorrow's lesson. Okay, we're going to be focusing on something called factoring by grouping. So I've got 4 little warm-ups here to get us ready for some of the skills that we're going to need. So a little GCF factoring on each of these. Notice in scenario number 1, they both have a common variable. What we want to do is factor out that common variable, which in this case is x squared. Dividing each by x squared will leave you with x squared plus 6. On the next one, there's no common variable, but there is a common divisor. So let's divide them both by 4. Dividing each piece by 4 would leave you with a 3y cubed minus 2. Now notice in this scenario, there's no common variable, but both the numbers are negative. When that happens, we should factor out that negative with the GCF. So I'm going to divide by a negative 3 this time, which is going to leave me with a 2m squared plus 3. So notice how our signs change there. And in my 4th scenario, got to have all 3 things in one here. We have a common variable, common divisor, and if the signs are different where the lead piece has the negative, you want to factor the negative out in that scenario. So in this case, I'm going to factor out a negative 4x. And if you divide both pieces by negative 4x, that would leave you with x minus 1. Okay? So those would be some different types of greatest common factoring that will help us in our lesson. All right, now what we're going to do is something called factor by grouping. For example number 1, I've got x cubed plus 8x squared plus 3x plus 24. Now notice, it's written in descending order of exponents, but there is no common variable for all the terms. This is missing a variable. And all these don't have a common divisor other than 1, so we have to kind of do a different plan of attack here. What I want us to do is, I want us to focus on the first pair, and then the second pair, and factor out the GCF. Out of each pair. So in the first pair, I have x squared is the common factor, and dividing both by x squared leaves me with x plus 8. Out of this pair, there's only a common divisor of positive 3, so notice how I put a plus there. Dividing each by positive 3 leaves with x plus 8. Now at this stage of the game, you should notice that both of these expressions have a common binomial. So we're going to factor out the common binomial. So they both have an x plus 8 in common, so I'm going to take that piece out. And what I like to do is cross off that common piece, and whatever's left over, which is not crossed off, that becomes the other part. So this is the factored form. And in case you're not sure if this is really the proper way to factor this, we can simply FOIL it back to check it out. So if I write this as x plus 8 over x squared plus 3, if we FOIL this back, x times x squared is x cubed, x times 3 is plus 3x, 8 times x squared is 8x squared, and 8 times 3 is plus 24. If I rearrange my terms, I get x cubed plus 8x squared plus 3x plus 24, which is what we started with in the problem. So that's how I know that we're looking good so far. Okay, for example 2. We got ourselves 5x to the 4th plus 3x cubed plus 35x plus 21. Good to go the same route here. We're going to factor out from these guys an x cubed as the GCF, leaving me with 5x plus 3. From this pair, they're both divisible by 7, so I take out a positive 7, and that'll leave me with a 5x plus 3. You know you're in good shape with these problems when this part and this part match up. If they don't, it means you made a mistake. Check your work quickly and see if you can find the error. So now they both have 5x plus 3 in common. Cross it off, and what I'm left with is x cubed plus 7. This won't factor again, nor will this, so that is the final answer. Example 3. 12y cubed plus 15y squared minus 8y minus 10. For the first pair, we're going to take out a 3y squared. When I divide, I will get 4y plus 5. Now notice, on the second pair, both of these are negative, so I want to take out that negative when I factor, and they're both divisible by 2. So I'm taking out a negative 2 this time, and that leaves me with 4y plus 5. So now I've got my match. I know I'm in good shape. So if I take out the common binomial, 4y plus 5, cross it off, that leaves me with 3y squared minus 2. Example 4. We got 5x cubed plus 3x squared minus 30x minus 18. Out of this pair, we're going to take out x squared, leaving me with 5x plus 3. And over here, both of them are negative again, so I'm going to take out a negative. 6 is the biggest divisor, and that leaves with 5x plus 3. These are the same, so all looks good there. So let's take out the 5x plus 3, cross it off. We're left with x squared minus 6 as the result. Alright, that's my 2-minute warning. Okay, let's go with one more example here. Let's go the TTT, the time to think. Alright, for this one, we would go with 3r cubed minus 2r squared minus 75r plus 50. Okay, from this first pair here, I'm going to take out an r squared. That leaves you with 3r minus 2. Now for this one, notice how they both have different signs, but the lead guy has the negative. So let's take out that negative. And the biggest number that divides 75 and 50 is 25. So that gives me 3r plus 2. And now I just noticed here, this doesn't match this. I must have made a mistake. When you divide by negative, negative divided by negative should be positive. Positive divided by negative, there was my mistake. So right there I caught myself with a careless mistake. But now that everything matches up, we got 3r minus 2. And I'm left with cross it off, r squared minus 25. Now the reason why it's the TTT, this won't factor again, but this guy will. We can use dots or that conjugate method. So bring down the 3r minus 2, but over here this will be r plus 5 and r minus 5, which means it could be factored again. So we have to kind of look to see if it can be factored again, make sure it's factored as completely as possible. Okay? So that's pretty much our set of examples. Hopefully you were able to follow this. Hopefully my first video went well, and hopefully you're not watching this before bedtime and have math nightmares. So thank you for your time, and I will see you guys tomorrow in class. Have a good night. Bye-bye.